Hi everyone, and welcome to the first lesson in calculus. This is going to be lesson P1, graphs and models. And so let's go ahead and get started. Today we want to talk about the graph of an equation. So a lot of what we're going to do here is just in preparation for calculus, and it'll be a lot of review and kind of just getting back in the swing of things. So in calculus we're going to be using several different approaches to study equations. We're going to look at them graphically, analytically, as well as numerically. Okay, so three different ways we have to look at equations. So just some vocab here. The graph of an equation, it's a visual representation of the set of all points that are solutions of the equation. A solution point, it's a point in xy coordinate that satisfies an equation. So an example would be the solution point 2, 1 is a solution of the equation 3x plus y equals 7, because if you plug 2 in for x and 1 in for y, this forms an equal equation. So we can go 3 times 2 plus 1 equals 7, and that is true. Now, we're also going to be using a table of values in here quite a bit in the first chapter at least. And this is a listing of several solutions of an equation. So there's more solutions. Now the easiest way to find this is to first solve the equation for y. So if we have 3x plus y equals 7, and we want to get y by itself, this is basic algebra here. We'll subtract 3x to both sides, and we call this y equals 7 minus 3x. Now in solving for y, this is our analytic approach. Okay, so using equations in algebra, that's an analytical type of approach. Now if we wanted to find these other values, we would just plug in other values for x. So we can plug in 0, for instance. So we have y equals 7 minus 3 times 0, and we're left with just y equals 7. And you can see here that's one of our solutions right here, 0, 7. And if we take a couple of these points, 1, 4, 2, 1, 3, negative 2, we would call this a numerical approach. Okay, so this is the numerical approach, listing of solutions to the equation. Now over here we have our graphical approach. Okay, now to get the graph, one way is you can take the numericals, all the set of points here, and plot them and then draw the line through them. So here we have 0, 7, and your graph might look a little bit different. I changed the x and y scale on mine. So we got the point 0, 7. We have the point 1, 4. Okay, we have the point 2, 1. And the point 3, negative 2. Okay, and then you can see the line that goes right through there. Okay, giving us the graph of that equation. So let's go ahead and try this example. You can try it on your own, and we're going to try this using a numerical approach. Okay, so if you want to try this on your own, you could pause the video and try it, or you can just continue to follow along. So we want to do this numerically. Okay, so it's kind of nice because the equation's already set up in y equals form. So it'd be very easy to make our table of values. We'll put x and a y. And I'm just going to go ahead and start at -2 and then work up from there. -1, 0, 1, 2, and 3. So your x values are ones that you can choose. It's our independent variable. And then what we want to do is go ahead and plug in these values into y equals x squared minus 2. So you can do this in your head. We just got -2 squared is 4, minus 2 is 2. -1 squared, that's 1, minus 2 is -1. Here we have 0, 0 squared minus 2 is -2. And then 1 squared minus 2, -1. 2 squared minus 2 is 2. And then 3 squared minus 2 is 9 minus 2 is 7. Okay, so once you get your table of values here, we're going to go ahead and plot each one of these points. So we have -2, 2, -1, -1, 0, -2, 1, -1, 2, 2, and 3, 7, and it's kind of up off the chart. So we can see here kind of what our curve should look like. So freehand this. It's kind of hard using the pad. You might have a little more success on paper there. I'll draw our arrows to show that it continues. Now, when we look at this type of numerical approach and then it feeds into a graphical approach, we can run into some problems. So plotting the points may not always give you an accurate graph. And that's why it's good we have several methods for analyzing equations. Okay? You can also see in the graph that we don't see all of the data because this graph keeps on going. Let's move on. So intercepts of a graph. We have the x-intercept, and this is the point where the graph intersects the x-axis. And so the solution to the x-intercept is always going to be some sort of a, 0. And you'll notice there the y value is 0. Now in the y-intercept, the point where the graph intersects the y-axis. So now the x-coordinate will be 0 and the y-coordinate will be something else. Let's go ahead and find the x and y intercepts of the graph of y equals x cubed minus 4x. So first, let's go ahead and find the x-intercept. Alright, if we want to find the x-intercept, notice the y value has to equal 0. So we're just going to let y equal 0. And we're going to substitute it into our equation. So we get 0 equals x cubed minus 4x. And now we just need to solve this equation for x. So this is going back to your algebra days. We have an expression equal to 0. So we're going to try to factor the right side of the equation here. So we can take out our greatest common factor of an x. And we're left with x squared minus 4, which is a basic difference of squares problem. So we have 0. We still have the x in front. X squared minus 4 factors to x plus 2 times x minus 2. So hopefully you're recalling your factoring skills there. And now we have 3 solutions to this. So this one would be x equals 0. Here would give us -2. And this one would give us +2. So the x-intercepts, however, are not x equals 0, -2, and 2. It is the points -2, 0, okay, which came from this one right here. So -2 is the x-coordinate. Remember our y was 0. Then we have 0, 0. Again, here's the x equals 0, y equals 0. And then the other one is going to be 2, comma 0. So here's your x of a 2, and the y was 0. All right, let's go ahead and find our y-intercept now. So if we let y equal 0 to find the x-intercept, what do you think we're going to do to find the y-intercept? Let x equal 0. And so we're going to plug that into our equation. So we have y equals 0 cubed minus 4x, or 4 times 0, sorry. And that equals 0. And it's the only solution. So the y-intercept here, x is 0, y is 0. It's the point 0, comma 0. Okay. Now notice the 0, 0 is going to be an x-intercept and a y-intercept, and this is how to find the intercepts. Also tells us some information about the graph. All right, let's go ahead and turn the page. All right, next we're going to talk about the symmetry of a graph. So we can have y-axis symmetry, and what that means is over the y-axis, if we were to reflect one side, it would be a mirror image of the other side. So you can see here this point x comma y becomes negative xy on the other side of the y-axis. And that works for every point along the graph. For x-axis symmetry, here you can see if we reflected each point over the x-axis, it would be mirrored on the other side. So x comma y now becomes x negative y. So in looking at these two things, which value becomes opposite or negative? Well, y-axis symmetry, the x becomes negative. X-axis symmetry, the y becomes negative. And there's one more here called origin symmetry. Now what that means is if we were to put a point at the origin and spin this thing around 180 degrees, we would have the exact same thing. Okay, so a little bit of rotational symmetry there. And so this side mirrors this side, but it's just rotated around. Here you can see x comma y becomes negative x comma negative y. And that works for every single point. So why is this important? Well, if we know that an equation has this sort of symmetry in its graph, if we can graph half of it, we know automatically what the other half is going to look like. So let's look at the tests here. So to test for y-axis symmetry, you want to replace x with negative x, and then check to see is that equation still the same thing. So you can see here this kind of x with negative x idea. For x-axis symmetry, we want to replace the y with negative y and see do we get the same equation. And again, here's the y and the negative y. And then for the origin, okay, we want to replace x with negative x and y with negative y. And you can see that's exactly what's happening here. And we want to check to see does it yield an equivalent equation. Let's do an example here. It says determine the symmetry of the equation y equals 2x cubed minus x. So there's no quick way to do this if we're going to follow the tests. So let's just look at y-axis first. So what it says is replace x with negative x. Okay, so we got y equals 2 times negative x cubed minus negative x. Now at this point, we want to go ahead and simplify this equation and see is it the same as our original. So here when we cube a negative, it stays negative, right? So this could be rewritten as negative 2x cubed, and then negative negative x becomes positive x. Now compare that with the original. Are they the same? No. Okay, so it does not have y-axis symmetry. So let's try it for x-axis. All right, so here we want to replace y with negative y. So we're going to write this as negative y equals 2x cubed minus x. And we want to get it to look like this. So we have a positive y here, so we need to change that and make that positive. So we're going to get y equals negative 2x cubed plus x. So just distribute the negative across. And there's really nothing else we can do. So is this equation the same as this one? No. So this does not have x-axis symmetry either. So let's try our last one, origin. So here we want to replace both x and y with their opposites. So we get negative y equals 2 times negative x cubed minus negative x. Okay, so let's go ahead and do the right side first here, which we already did. And then distribute the negative. All right, and now we're going to check our equations. Okay. Is it equivalent to the first one? So when we're looking here, we get 2x cubed minus x. Those are the same, therefore this has origin symmetry. All right, for our next example, we want to sketch the graph of x minus y squared equals 1. You know, there's many ways you can do this, but we're just going to do this by first finding if there are any intercepts. So we're going to look here for an x-intercept. So again, finding the x-intercept, we let y equal 0. And very important, write the solution point, not just x equals 1. Okay, we can go ahead and plot this point. We get 1, 0. That's going to be our x-intercept. Let's check if there's a y-intercept. So here we let x equal 0. All right, let's distribute the negative there. All right, and you guys should remember this. So if you take the square root of a negative number, okay, it's not real, and so we can't show it on our Cartesian plane. So we don't have a y-intercept here. Let's go ahead and solve this equation analytically. So we're going to solve this for y. We'd have to subtract x. And then we would have to distribute the negative. And then we would take the square root of both sides. Okay, now at this point, let's go ahead and use our table of values and examine this equation numerically. So you can choose whatever you want here. I'm just going to choose a couple. Since I'm dealing with square roots, if I want it to come out nicely, I would want to try to pick a perfect square in here. So a perfect square is like 1, 4, 9, 16, so on and so forth. So, or what would make this equal 1? Well, if we put 2 in for x. Okay, so then we have the square root of 1, which is 1. What would make this equal 4? Well, if we put 5 in. Okay, so 5 minus 1 is 4, square root of 4 is 2. Now you can see our graph doesn't even go past that, so not really useful there. Now, what if we did something like 0? What if we put 0 in? Okay, again, if we put 0 in, we get a negative number, so it's not going to work. And actually, if you put anything less than 1 in, you're not going to have an answer. So nothing's going to work there. So let's go ahead and plot these 2 points. We have 2, 1, and and 5, 2. You can kind of see we're going to get a curve like this. Okay, a lot of functions with square roots are going to look similar to this. Now there's something else we need to check, and that is the symmetry. So let's go ahead and test for some symmetry, and let's look for y-axis. Y-axis, we want to replace x with negative x. So we get negative x squared minus y squared equals 1. Okay, there's nothing really we can do to that to get it to look the same, so that doesn't work. How about x-axis? So replace the y with negative y. So now we have x minus negative y squared equals 1. When you square a negative, it becomes positive. So lo and behold, we're left with our original equation. So we do have x-axis symmetry. And so what that means is we can mirror this side on the bottom also. And it would give us the point here 2, negative 1, also 5, negative 2. Now I understand in the past, you've been taught, oh, if it's a y squared, it's going to be a sideways parabola. And yeah, you've learned all the rules there, but again, we're learning again how to reanalyze these equations. And so that's the important part, is how we come up with all these rules, and that's what we've been doing. So let's move on now to points of intersection. And it's going to be our last example, so thanks for hanging in there. We're almost done. So a point of intersection of the graphs of two equations is a point that satisfies both equations. So anything that intersects, it's the same in both of them. So we can find the points of intersection by solving their equations simultaneously. What we want to do here is solve both equations for the same variable. So let's go ahead and solve both equations for y. So the first one, we get x minus 1. And for the second one, we get x squared minus 3. Now this is what it means to solve them simultaneously. If you look, both equations are in the form y equals, and so now we can use the symmetric or substitution property to combine these two equations into one. So we're going to link these with the y, and we're going to get x minus 1 equals x squared minus 3. Now what we're going to do is going to get an x value that works in both equations. So let's go ahead and solve this. So there is a power of 2, so we want to get this equal to 0. So we have x squared minus x, let's see, plus 1 minus 3 is negative 2. And we want to factor this. So we have x minus 2 and x plus 1. So the solutions here are x equals 2 and x equals negative 1. So what this tells us is these two equations intersect at when x is 2 and when x is negative 1. But we want to find actual points. So we need to substitute the x values back into an equation to find the y. And this equation is definitely the easiest, so we'll try this here. Y equals 2 minus 1, and that gives me 1. So the point there is 2, 1. And if we plug in negative 1 for x, we get negative 1 minus 1, which is negative 2. And so I get the point negative 1, negative 2. All right, and those would be our 2 points of intersection. All right, thanks for watching, and I don't know, it's the end of the video. We'll see you in class.